All right, welcome back to Mr. P Helps with Algebra, the Unit 3, Topic 1, SLT number 8, making more money. We're going to be able to predict correlation coefficients and scatterplots. All right, here we go. So we're going to start off with finding the distance away from A. B is 1 away from A. C is 1, 2, 3, 4 away from A. D is 1, 2, 3, 4, 5 away from A. E is 1, 2, 3, 4, 5, 6. F is 1, 2, 3, 4, 5, 6. Because remember, distance can only be positive. Distance away from something. 1, 2 away. If you add these all up, 6, 12, 13, 14, 19, 23, 24. So it looks like they add up to a grand total of 24. What is the average distance? 1, 2, 3, 4, 5, 6 of them. 24 divided by 6 means the average distance is 4 away. 1, 2, 3, 4. And C would be the only point that is exactly 4 away. Now, the reason why we have this one up here is because this is going to get us thinking about distance away from the average, which is, when you're talking about a scatterplot, when you have a trend line going through the scatterplot, is going to be the residual. So in the future video, you're going to see us talking about residuals. Correlation coefficients. So just a quick reminder of how this works. If the data is going up, it's a positive correlation coefficient. If it's going down, it means it's negative. So anytime you have a negative, it means the data trend is going down. It means one variable is decreasing as the other one is increasing. If the data is going up, that means as one variable is increasing, the other one is also increasing. And if there's no correlation, it means that the two variables have nothing in common. It's just random dots all over the place. Now, 1 means the data is in a straight line, either going up or down. And 0 means that it's just spread out all over the place. So anything in between 0 and 1 shows how weak or strong, meaning how close the data is away from the trend line. So 0.9, notice that the data is all very close, whereas 0.5, the data is a little bit more spread out. 0.3 would be even more spread out. The closer you get to 0, the more spread out the data is. The closer you get to 1, the closer to a straight line it is. So if we were just going to make some predictions, so I would guess this is more like a 0.3 to 0.5, somewhere around there. It's up, so it's positive. This data, I would say, is like a 0.7, some 0.8 maybe. This is going to be a negative 0.7 or 8. I know I kind of missed the data there. And this is no correlation. That's pretty easy. Remember, we're just making guesses. Now, a line of best fit, I think a curve of best fit would have fit this data better. We'll talk about that more in the future. But if it was a line of best fit, I think this data is pretty spread out. So maybe like a 0.3, 0.4. Oh, negative 0.3, sorry. This one's nearly a straight line, but it misses at the very end. So that's going to be like a 0.95. This one I would guess around a 0.3, 0.4. It's pretty weak. The data is very scattered. It's not very close to the line. This one, now, I know it looks like no correlation, but I'm going to say the more time you play, typically the more fouls, possibility of getting a foul. So I think there is a positive correlation. If you play a very little amount of time, your chance of getting a foul called, and we're talking about soccer here, I assume, is very, very small. So even if it was basketball, it doesn't matter. So anything that could be a foul. The less time you play, the less chance you have of getting a foul. All right, so now we're going to talk about what do you notice about the data. Now, this is a pretty controversial lesson because we're going to be talking about the average incomes from 1991 to 2005 between men and women. Now, clearly, when you look at the data, it's pretty obvious that it's not fair. That women in every single year were making less. As a matter of fact, in the very beginning, they're making about half as much, but by the end it was more like 56, 57%, I think, when I figured it out. So it's getting closer and closer as the years go on. The women's salaries were catching up, so these must have been increasing more than these were increasing. So what we're going to actually do is we're going to draw a scatterplot, and this is how I would have done it for the women. I'm going to use the same increments for both men and women. Yeah, the men is back here, so I'll let you do this one on your own. So we just take a look at what I did. I wanted to save some time, so I did this ahead of time. So I made the X, so years since 1990, from 1 to 15. Now, I don't like using years for my X, so I changed these all to 1, 2, 3, 4, 5 years since 1990, so forth, all the way up to 15. And then for median incomes, I started at 10 because the lowest number is 18,000. That's below 18, and I had to go by 2s. Now I know I probably could have gone by 1s for the women's data, but I wanted to use the same scale so it's not misleading for using the men's and women's. And the men's went up to 40-something thousand, so I went by 2,000s. 10, 12, 14, 16, 18, 20, 22, 24, and so forth. So then I plotted the data, which is in red, and I drew a purple line through it, which is the trend line, which basically shows the trend of the data. So there's a couple of years where it goes up significantly, and there's a couple of years actually it goes down that you see like right here at the very end. Then there could be some reason that happened in maybe 2004, 2005. There is a start of a recession during that time, so I guess that's really not that. This is real data collected by the U.S. Census Bureau, by the way, which is a division of the government, which actually, that's what they get paid to do. They get paid to collect statistics using a census, which happens every 10 years. And we use that to make predictions for what the future is going to be like how many people are going to be in it, living in each city, and so forth. Okay, so moving on. Estimate the correlation coefficient of this data. I think this is pretty strong because, for the most part, I know I kind of missed. I should have angled this a little bit better right here. For the most part, the line is going through most of the data. It's very, very close. So I would consider this more like a 0.8, 0.9. I think I remember when you put the data in the calculator, you end up getting like 0.96. I want to say is this, but you're going to need a calculator. So what you're going to need to do, I'm going to describe the process right now. You're going to press Stat. You need a TI-83 or TI-84 Plus or Silver Edition, doesn't matter. So press Stat for Statistics, which is right below Mode, I believe. Then go to Edit, and then what you need to do is you need to put the data in. So the 1, 2, 3, 4, 6, 7, 8, 9, 10, and then put all the numbers. So L1, you're going to put all the X's, and then L2, you're going to put in all of the Y's. Once you've inputted all the data into the calculator, then you're going to go to Stat Calculate 4. But there's a little issue. Now, you might have seen this in the last video. You have to turn diagnostics on in order to get R. R stands for the correlation coefficient. So the way to do that is you press Catalog, which is second 0. Second 0 gives you the catalog. You scroll down to Diagnostics On, press Enter twice, and then it should say Done on your screen. Once you have done that, then, if you go to Stat Calculate 4 for a linear regression, it should give you the R now, and the R happens to be the correlation coefficient. I believe it was pretty strong. It was like 0.9 something. I don't have a graphic calculator on me like for all my videos. With the addition of this data, so now we've got more data from 2006 to 2007, and we're asking how would you now estimate the median income for men in 2015. So now what you should notice is the men, their average incomes are decreasing. Like I said before, we had a pretty big recession during that time. We had the bubble burst of the housing market. So it doesn't shock me too much that the average income in the United States for men was decreasing. Now the women's, let's see, increase here, decrease, back to increase. The women's weren't as affected, I would say. The men went down like $4,000 overall, whereas the women's, they ended only $1,000 below where they started in 2006. So how would I estimate? The median income for men would have decreased quite significantly, and the women's wouldn't have decreased as much. How appropriate is a linear model for men's and women's income in 1991 to 2011? And justify your answer. I believe I just explained that. How appropriate is the linear model? Oh, well, I would say, if you look back at the data, the line is a very good model. I don't think this data is curving very much. I think a line does meet it. Now, what I do want to note is that, remember, it does go down a little bit over the years, but if I straighten this line out, it's still a pretty good model. It's not curving enough to use a hyperbola or a parabola. So I would stick with the linear model for this. All right, so homework. Create a scatter plot for the data table below. Do the English and history scores have a positive or negative correlation, and why? All right, so English scores. I'm going to put English on the bottom. You can do it the other way around. Doesn't really matter. I'm going to put history scores over here. Now, I'm going to assume that this is about 20 blocks, and English looks to be the numbers about up to 70. So I think I might have to go by 5s. 5, 10, 15, 20. 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And I think that's far enough. I'm going to do the same thing going the other direction because the numbers are pretty similar. 5, 10, 15, 20. Now, I'm going by 5s. That's on increments of 5s. I'm just not labeling every single box. 25, 30, 35, 40. 45, 50, 55, 60. I need to keep going. 65, 70, 75, 80. I think that should be far enough. 60, 65. 60, 65, about right there. 53, 59, 53, 59, about right there. 44, 57, 44 would be about right there. 57 would be about right there. 61, 61, just past 60, just past 60. Okay, that's going to be really close. 70, 67, 70, 67, about right there. All right, so do the English have a positive or negative correlation? Well, that definitely looks like the data's going up. Do English and history scores have a strong or weak correlation? Now, they look pretty strong. It looks like they're kind of in a straight line. So I would say that would be a strong correlation. All right, as always, thanks again for watching. Please give it a like if it helped you learn something about correlation coefficients and how to use the calculator to do that. And subscribe if you haven't done so already. Thanks again for watching. Have a wonderful, wonderful, wonderful